expanding Ethereum's proving landscape with Ethrex. So Leandro, Ferrigno, also from LambdaClass, aligned.
Okay. Hello. Thank you for having me here. Well, the idea for this talk is to talk a little bit about the Ethrex and the idea that we have of expanding the proving landscape with another client. If we take a look in the execution client landscape, the diversity is quite good. There are many great clients, but when we start looking into the proving side of things, most of the team here uses like just one only client, getting aside CK Sync that uses their own like OS. So I wanted to bring here Ethrex, which is the execution client that we have been working over the last year. Mostly, one thing is that we love Rust, but besides loving Rust, we have been working in this field for many years, and we realized that code bases were quite complex, and we have been always talking with different teams, struggling with complex code bases. So we decided to, okay, why not building a new one? Why not add some new piece of software to this like field? And that's when we came up with Ethrex, the idea that it should have minimal dependencies, much less lines of code. We shouldn't have like clever abstractions all over the place, and we should have concurrency only where needed. And I guess that this last point is quite essential for proving. And while talking about this ecosystem explicitly, I've been hearing today that most of you see execution as latency. That's weird for us, but you see us as latency. And well, I think that with this code base that we have, there is a great room for improvement, and we will be able to gain much more over this latency that you see us. We have a shared code base between the DL1 and the CK rollup that we're building, because Ethrex is both for DL1 and CK rollups. So we don't have a duplicated code, and we ensure consistency. Everything that we do is consistent with CK. Also, we have been building this Ethereum pre-execution tooling, enabling us to execute and prove Ethereum blocks in different CK VMs easily, like a separate repo. I will show later a QR. So for everyone, like we are already integrated with RE0, SP1, and CISC, and we have been working with Brevis, with Pico from Brevis, and with OpenVM for a while to include us. But right now, this is like our repo, and it should be very simple to have your own guest program. In this experiment, we just need to handle the stateless execution for any CKVM that we want, and it should be pretty easy. Actually, with CISC, we just did it in these last couple of days, working directly with them, and it was super easy to integrate. Exclusively talking about minimalism, we really enjoy showing this small graph. Like, okay, we are 1/3 of lines of code and other clients, and well, this is for us something that we celebrate a lot, and we're always taking care of. It should be easy to change. It should be easy to improve. Also, we have less than half of dependencies. It's not easy to compare dependencies, but with clients built in the same programming languages, we are above half of the dependencies than they have. And some performance, you won't be much interested looking into these numbers here in the proving landscape. But what I wanted to show is that we're working a lot with performance. What you see here on your left is all the achievement that we have done over the last month. We did a 10x on the last month on the gigagas by block. And well, block time reduced by 10x. This is quite amazing. These are not very good CPUs. With better CPUs, we have a better performance, of course. And we still have a lot of improvement to be done. We're working on that. and we are confident that we can achieve much more performance. And not only with this, but also we're like adapting the guest programs for the different CKVMs that you have. These are the numbers that we have and that we have recently incorporated with the system. And here you can see, like for example, for SP1 Turbo, we are like in from 2 to 12 minutes. That's a lot. That's obviously not real time. But well, yesterday and the day before yesterday, with the help of SIS that share with us their multiple GPU thing, their GPU farm with 16 5090, well, we achieved proving some blocks in the range between 6 seconds to 15 seconds. And this is with what we have at the moment. We haven't done anything in particular to adapt or to improve. So this is like the starting point. I think that as a starting point is a very exciting starting point. And well, what I'm asking here, we will love to work with all of the people that are in the room. It's very exciting for us. We have done a few collaborations as well with different teams, for the Ethereum Foundation, the CKVM team. We help them integrate Ethrex in their CKVM, and we're very grateful with that because, well, that gives us also a place where we can show what we have been doing. And we are reviewing their standardization proposals for different CKVMs. And that is a great effort, not easy to be done. And well, I think that they are doing a great job over there, and we are eager to help them. And the idea is for us to become fully compatible with Array, which is like this effort of unifying the interface written in Rust. Our future work on this, as I said, this is just the starting point. We need to lower our proving times with a single CPU. Those are not great. We have there with 33 seconds or 60 seconds for 2 minutes for SP1. We need to lower those numbers, but we also need to work in multiple CPU proving. Also pipelining execution to reduce latency. We need to integrate, and we want to integrate with more CKVMs. And well, we want to work on the integration with Array as an alternative for Ethrex and this Ethrex replay, which is this execution tooling that I mentioned. This is a link to the repo, but if you cannot scan the QR, if you want, you can just look for Ethrex replay in LambdaClass repositories. And well, I think I'm just in time. This is us. If you want to follow us or give us some love in Ethrex repo. We'll be around. We have been around all this week here, but we are pretty easy to find. And we will love you to reach us out or to answer when we reach you out for integrating with Ethrex. Okay, thanks.
Thanks so much, Leandro. We've got time for one question, if you're open to it. So
that's it.
Are you looking into doing ZKVM specific optimizations other than using precompiles, like using hints or ZK-friendly hash maps?
Yeah, that's a possibility that we are exploring, actually. It's something that it will be great to discuss with the specific teams working in CKVMs, but yeah, definitely it's something to explore.
And then final question. How much of your performance optimizations are due to SIMD instructions and other CISC and GPU optimizations that aren't available in RISC-V as A? Okay,
to be honest, I don't have the answer for that, but we can discuss later with the team. All the CISC integrations has been done in the last 2 days that I've been like all around the place and without
totally
seeing
understandable.
what my team did. Okay, well, happy to continue later.
Okay. Thank you very much.
Okay. Thank you.
Thank you.